for our next session, we would like to invite Dasun Theekshana, who will be briefing us on development and testing frameworks. And he is a fourth year data science undergraduate at SLIIT. So over to you, Dasunaya.
Thanks a lot, Noli.
Yeah.
I hope you can see my screen.
Yes, we can see.
Yeah, a very good evening to everyone who's joined in for ITP Guide 5.0. I am Dasun Theekshana, and I am fourth year data science undergraduate here at SLIIT. And I'm also a member of MS Club of SLIIT. And today in this session, I am planning on giving a brief introduction and some pointers about development frameworks and testing frameworks. So talking about the plan for the evening, so talking about the content, first of all, I'll be talking you through what a framework is and why we use frameworks, and then I'll be going on to the differences between libraries and frameworks, and then I'll be talking about technology stacks and how we choose the perfect one for your project, and finally I'll be also talking about testing frameworks. All right, without further ado, let's start off with frameworks. All right, so what is framework? So I think some of you might have known about frameworks already, and most of you might not know about framework. So simply put, framework is basically a structure for developing software applications, and it basically serves as a foundation on which developers can build programs for a specific platform. So what I mean by this is, as a programmer, you might have, so since you're in second year, second semester, you have done some amount of coding on your own in university projects, and we know that if you don't have you start code, if you want to code and if you start coding without a specific plan or a specific foundation, then probably you will be writing a lot of unnecessary code, and it sort of brings down your productivity. So that is why this concept of frameworks are in place. This, as a programmer, you don't need to start from scratch when you have these frameworks designed to help you with your projects. Frameworks are software that are like developed and used by developers to build applications, right? And what frameworks allows you to do is lets you focus on the high level functionality of your applications, what you really want to do, instead of worrying about low level functionalities like code views or whatever. And that really increases the productivity in these complex procedures of software development, right? And next up, so software frameworks are typically associated with a specific programming language. For example, if you take Java language, there is, as you know, as well, there's Spring Boot, and if you take JavaScript, there are a lot of frameworks, React.js, Angular, and all that. And these frameworks are suited to different type of stuff. These frameworks perform like specialized in performing a specific type of task, whether it's front-end development, back-end development, or mobile development. So, for example, let's take JavaScript. So, in JavaScript, React is a very popular for example, let's take JavaScript, yeah. Yeah, and so basically it's used for different types of tasks, and then so to give you a further explanation about frameworks, I'll be giving you sort of an analogy. So I'll take a house for an example, right? So when you're building a house, you know that you don't just start off with you don't just gather some bricks and some cement and just start building, right? What you do when you are building a house is, first of all, you consult an architect and an engineer, and you first of all come up with a plan, right? A structure of how you are going to build this house. What they come up with is they come up with a specific set of rules, right? They say this: you have to have the foundation. The foundation must be this deep, and the columns must be like this. And what this basically allows you to do is it gives you this structure upon which where you can start building the house, and it becomes the whole process much more easier and much more speedy. And this is basically what a framework does in a software development point of view, right? Uh, what it basically does is um, it sort of gives you this structure around which to base your code, base your development process, and gives you a set of rules and regulations to which to follow, so that your software development and your coding process get much more streamlined. That's the whole idea of using a framework. So next up, we'll be looking at about why we use a framework, right? So first of all, it's to save time and reduce the risk of errors. As you know, like um, if we if we start off like without a plan, a game plan, or specific tools or anything, we will be spending a lot of time just writing and writing and writing a lot of code without any structure, and this might take a lot of time. Uh, it's in the process of software development, it's very time based. You have very time restrictions, and saving time is an important part. So frameworks significantly reduces this time by its the structure with their code structures and rules and all that. And it also reduces the risk of errors, because since you're not writing all these lines of code without standards, uh, you reduce the risk of errors and increase the ability to give out quality software. And then next up, it avoids like duplicate and repetitive code. What frameworks allows you to do is, since you have that structure already built in, what it allows you to do is, when you need, then let's say you are building a like a multi-page web application, and you have to use a component. So if frameworks are not in place, you have to write the same code all over again for each page, right? But in the case of framework, it allows you to reuse your code, and it since because it allows it, it avoids a lot of duplicate and repetitive code, and that it significantly speeds up the development process. And then you have secure code. What that basically means is, like, frameworks takes care of security measures of your app. They have built-in security measures like data sanitization, centralization, and authentication. So secure code means like quality code. So once again, it gives you much standard software for you, and simpler testing and debugging. This is quite obvious, because since you have less of duplicate and repetitive code, and since you have reduced risk of errors, what that basically means is, in the testing process, in the quality assurance process, then testing code will be much more easier. And once again, as I mentioned before, it's reusable and scalable as well. If you want to increase your demand, once again, you can you have the structure, you can you use your code, and once again, for if the increased demand for your software application, you can scale very easily. And when it comes to deployment and maintenance, having frameworks in place much more easier, because it follows a consistent frameworks. Application written with framework like follows a consistent coding approach. Like, it makes it easier to understand and maintain the code, and at the same time, it's easy to deploy your code as well, right? Next up, so the difference between frameworks and libraries. So most of you have known about libraries as well, and maybe you might not have known about it. And so libraries and frameworks are something a bit similar, but they have the differences. Usually, students usually get these two mixed up. So there is if you take library, a library is basically a predefined collection of reusable methods and functions, all to perform specific well-defined operations. So it's basically reusable code, basically reusable code, right? Reusable methods and functions. And frameworks actually also has these libraries. Like frameworks itself has these reusable methods and functions, but the way these two differs from each other is how you call your code inside frameworks and libraries, right? The key difference here is that when you're using a library, you can call these libraries, methods inside the libraries anywhere in your within your code, right? But in the case of frameworks, that's different. In the case of framework, since there is that existing structure and these rules and regulations, you cannot use them anywhere you like. You have to adhere to those rules. Like basically, when you call a library, you are in control. But with the framework, the control is inverted. Like framework calls your code, right? This concept is is called the inversion of control. Um, right. To give you like much more clarified understanding about it, so you can see this diagram, and here you can see have the frameworks, and as you can see, the framework also contains libraries. Like framework contains the reusable code, but as you can see, when it comes to your code, the framework calls your code. But on the other hand, when you're using libraries, you can call the functions of methods in your library within your code, right? That's the biggest difference between um, libraries and a framework, right? So when we use a library, we are in charge of the flow of the application. We are the ones choosing when and where to call the library. On the other hand, when we use a framework, the framework is in charge of the flow. Like framework itself is making the calls towards our code, right? Like like briefly, a framework is more complex with more behavior built in, right? All the control flow is already in framework. Right. I hope you get what I'm understanding about frameworks and library. So next up, I'll be giving you some examples about for libraries and frameworks. I'm probably sure you know some of these technologies. On library side, you have React.js, very popular front-end framework. You have Socket.io, which is for like real-time applications. You have Redux, which is a library used for state management. I have jQuery toolkit, and on framework side, you have Vue.js, AngularJS, you have SvelteKit, which are like JavaScript-based frameworks. You have Laravel, it's PHP, and you have Express.js and Django, which is Django is a Python-based framework for backend. All right. Next up, we have the technology stack. So what in simple terms, what the technology stack basically means is it's a collection of software services, programming languages, frameworks, and basically everything you use in your software development process. Yeah, all the technologies that you use, right? So if you're using the front-end technology that you use, the back-end technology, and the software database service that you use, and also if you're like using container, you have containerized your application, like if you're using Kubernetes or Docker, that also includes your that's also comes under your technology stack. And if you're deployed your application in cloud service like AWS or Azure, that's also a part of the technology stack, right? And even version controlling system you use, you can basically take under your technology stack, right? And in terms of for the sake of simplicity, what we take is we mainly divide this into two. That is front end and back end technology, right? Um, so front end technology is also called client side technology. So this is what the users see and interact with within a website. When you visit a website or like let's say a mobile application, what you see is basically is the front end or the client side, and this usually consists of technologies HTML, CSS, JavaScript, and other like JavaScript-based frameworks and libraries such as React.js and Angular, right? And then moving on to the backend, this is also called the server-side technology. This is basically what happens behind the scenes, like the whole functioning of the application that you cannot see, right? And this includes, the programming languages that you use, the servers or the microservices that you use them, and the database service that you use, and also the operating system. Right. So yeah, to give you a clearer understanding, you have this um, diagram that shows the server-side technologies and client-side technologies. And as you can see, how they communicate with other in this diagram, it says the interest. So how exactly these two communicate with each other is through a thing called APIs, which Dinwan also mentioned. So APIs are like application programming interfaces. It's basically a set of like rules or protocols which are in place for software components to communicate with each other. And these are how, like, backend and front end basically speak to each other, get their data to the both sides, right? And you learn more about this in future sessions as well. Right. So next up, you have a couple of popular technology stacks and frameworks and libraries. So you have in the front end side, you have Vue.js, you have Angular, React, Next.js, So these ones, sorry, so Vue.js, Angular, React, Next.js, all are based on JavaScript. Svelte and Flutter. Flutter is actually a mobile development framework, and your Backbone.js. And then on the backend side, you have Django, which is a Python-based framework, plus also a Python-based framework, Laravel, PHP, and ASP.NET Core. It's developed by Microsoft. It supports like C# and Visual Basic. So Ruby on Rails, they have Spring Boot, as I mentioned before, Java-based framework, and Node.js, which is like a runtime environment for JavaScript. Express.js once again. And then you have this concept called full stacks. So the concept of full stack is these like front end and back end and all these technologies are bundled together. Uh, though these technologies like perform well with each other for specific development use case, right? So, for example, let's say this mean and burn. I'll come to these uh, uh, in the later slide. So these stuff are very popular these days, and it's used a lot of these days because it allows you to develop like fast and scalable and like data-driven applications, right? Because of how these technologies like work with each other. But these are not applicable for every single use case. Like you can't use Mertec when you like or Mealtech when you're developing mobile applications. So this depends on your use case. You can choose go to one of these full stacks. So these are some popular examples for technology like full stacks. As you can see on screen, you have the mean stack mentioned in the user sessions as well. So in this case, you have MongoDB as the database system, Express as uh, the backend framework, this is a JavaScript-based framework. I have AngularJS and Node.js. And in the case of Man, only so React is used as the front end library instead of AngularJS. And we have the Maven stack. So in there, the content of framework becomes Vue.js. And you also have talking about the mean stack, it's as I mentioned, it's like lightweight and fast and scalable. It makes a great choice for like building large, complex web applications. And it's very data centric because MongoDB is like a NoSQL database that is well suited for handling large amounts of unstructured data and provides high performance. So that's why this these mean and Mern and Maven has become quite popular these days. And you also have one of the earliest sort of full stacks out there is Lab framework, which is not, I think, quite popular these days actually. So we have in that in that case, what happens is PHP is your front end scripting, and Apache is the web server, and MySQL is the database system, and else as well enough, which is the operating system. All right. And next up is quite important part, which is choosing the technology stack. And here I have on the screen some of the most important factors that you should consider when selecting a proper technology stack for your project. And first and foremost, I think I have listed out the most important factor to consider, which is the requirements and objectives of the project. So in your project, you have 8 people together, and you choose a project to develop, right? Maybe some kind of mobile application or a chat application or real-time application. So depending on the first thing you should consider is you should choose technologies depending on what you're developing, right? So if you want to build a mobile application, you should look for mobile development framework, right? So that's the first, like if you're real time, if you're planning on building a real time application like that, you should look for frameworks which are like fast, and which are fast, right? Have much more performance. So that is the main factor to consider. And then you have these other factors as well. You have the skills and knowledge of the development team. In your case, it is your ITP group, your 8 members. So what I mean by skills and knowledge is that if you have if you already know about a certain technology or a framework, then you can probably decrease the time that you spend. Like if most of your if all the 8 people know about a certain technology, and you can significantly reduce the time you spend on learning. But I'm in no way, um, saying that you should stick to what you know. I believe that you should always explore, especially the demanding technologies out there. And then you have another important factor, which is community and documentation. Some programming frameworks and some technologies out there have a bigger community behind it, which basically means like it is very popular and used by a lot of people in the industry. And that means like if you come across a problem, if you um, get stuck in the middle of your development process, you have a lot of resources such as Stack Overflow, and you can go there and you have a much more chance of solving your problems. And so documentation as well. Some the more popular, so more like community behind it, the documentation and the sources basically will be much more higher. But that once again is not some that should not be the main factor that you should consider when you're choosing a framework, especially for ITP guide, because at the end of the day, you should should not be looking for the documentation in the community. You should be looking for how the technology which you can through which you can develop your application, right? That you have chosen, and you have scalability, which basically means if you're planning on scaling the application, scaling your web software, then some frameworks facilitate that more easily than some other frameworks. And then time to market. So what I mean here is that you have to provide an end software product at in a certain time. In your case, is the deadline for the ITP project submission. So some frameworks might take longer to learn, and the development process might take long. So that is something to keep in mind when you consider it. And then you have user experience, which basically means how the end user perceives it. Some frameworks are much more user friendly and much more like uh, responsive. So that's what I meant by user experience. And then you have development costs. So, so, so basically a development process has, at least in the industry, that it includes a lot of costs, for software um, um, and the services and the infrastructure. But in your case, you don't have to worry much about development costs, because a lot of frameworks and libraries out there are open source. And if you want like infrastructure, most of the platforms out there provide like free trials, and especially for your university mail, you can get especially for Azure platform, you can get cloud services. So don't worry that much about development costs, but keeping that in mind as well. And lastly, you have security. And I have to say once again that this doesn't matter. If, like the most important factor is the requirements and the objectives of the project, what kind of project that you're developing. That sort of dictates how the whole process of selecting a software framework or library or technology. All right. And these are some few pointers that I thought I'd mention. How if you can if if your project comes with many like are using input order operations, you offer the JavaScript framework, especially because it's very it's very in JavaScript frameworks are faster. And then you have if you're looking for like scalability, go for frameworks like Django, Node.js, and Ruby. These are not limited to these three, but can go search on their own. These are considered to be scalable and frameworks that support scalability. And you have if you're building a real application, go for like Node.js, Express, MeanSec, and Ruby on Rails. And once again, these are just few pointers. There's your uh, your project might not include either one of these, but then in that case, what I suggest you do is go search on your own. And finally, about as I mentioned before as well, it all comes down to the requirements of your project. So if you're developing a mobile application, you can't go with web application development framework, right? And another thing we should consider is that some frameworks are good for some functionalities more than the others. Like as I mentioned before as well, like for scalability, there are certain frameworks. If you're looking for scalability, there are some frameworks that supports it more than the others. If you're looking for like building real-time applications, some frameworks supports them more than the others. And for example, if you're building like a real-time application, like that application, then you need frameworks that are considerably fast, right? And there's no one perfect framework for all kind of project, and that's why I think you yourself should go search according to your project what's the best framework that I should use. And also as I mentioned as well, look to like as the so when you're learning um, so if you've selected, okay, you've selected a project and you've selected the framework. So when you're learning that framework, just don't just go look at YouTube videos and just do it according to that. Try to understand the concept comprehensively, so that because at the end of the day, when you go out the industry, you go to an interview, that's what you're going to be asked. You're going to be asked the concept. So keep that in mind as well. Just don't stick to YouTube videos and focus on the concept, because at the end of the day, that's what because the technologies are evolving. If you don't have the concept in place, then you might be in trouble. All right. And next up, are we going to software testing frameworks? Okay. So first of all, moving on to testing frameworks. I need to talk about like what is testing. So as you know, in the software process, what we basically do is we are creating a product, right? A software product, and we are giving this to and basically giving this a product to an end product to a consumer. And these consumers expect a certain level of quality from the product as well, and they expect from us. They have given us certain kinds of requirements that the software should fulfill, and it's our duty as developers to fulfill all those requirements and come up with a quality product, right? And that's why software testing is in place, and that's why software testing frameworks are in place, right? And okay, so here are some reasons why testing is important. So first of all, it helps to ensure that the code is working as intended and meets the requirements of the project. So when clients come to us, they come with certain requirements, right? This application should do this, right? At the end of the day, when you're giving up the project, you should make sure that your application that you develop should do those functionalities, and that's to ensure that these functionalities are working. That's one of the main reasons of the testing of quality assurance is there. And then also to identify and fix or bugs or like fix bugs or defects in the code, right? If your code is not up to that standards, then your consumers like the consumers expect a level of quality from the application that you build, and if it's buggy and defects, then it's like not good for either uh, the consumer or in your part, right? So that's one of the reasons my testing is used to identify bugs or defects in the code, and it helps to prevent regression. So what I mean by regressions is like if you fix a bug in one of the components, and if it affects the other components in the software in your application, that's called a regression. So testing is there to identify if there's regressions, like if one changes the other thing. Then to prevent regressions, testing is very important. And once again, to increase the maintainability and extend the life of the code, right? That what that means is like uh, you have to make sure like through testing that there is a certain quality to the code, there's a certain structure to the code, and through this testing, what you basically do is you increase the maintainability and extend the code and the reusability. And also, very important is catching like security vulnerabilities and prevent exploitation. So security is especially important, when you're dealing with sensitive data, especially for consumers. So the testing should make sure that your code, your applications are secure, and that's a really important part as well. All right. So there is a lot of kinds of software testing methods out there, testing types. So I've listed out some of the quite important ones that's here. So first you have the unit test, which are testing your individual components. Like testing your software components individually. So that's what unit testing is, and you have integration testing, which is testing your components like after you'll have like integrated with them with each other like as a group. You're carrying out testing. So that kind of testing is called integration testing, and you have performance testing, which is there for to test whether your application scales according to demand. So that's where performance testing comes in, and you have security testing, as I mentioned before, to ensure that your application is secure and has no vulnerability. And usability testing, it's basically testing whether it's user friendly and it's responsive and all that. And then, as I mentioned before, you have the regression testing, which is to make sure that solving one bug in one component doesn't affect the other components, and it has a regression effect, right? So there are a lot of other types of software testing types out there as well. Feel free to like explore these as well. And next up, you have test automation tool. So So as manual testing, like writing test cases on your own and uh, doing, writing test cases, especially for like a huge, when your development project is huge, it's a fairly like a wasteful practice for humans to like keep doing the same thing over and over again, like writing test cases manually. So that is why test automation has come into place. So test automation is basically the practice of running tests automatically, managing test data and utilizing results to improve the software quality. So what test automation tool does is it automates the whole process of like writing test cases and testing your code, right? So finally, I'll be going through some of the most popular testing frameworks out there. Yeah, first of all, you have Selenium, um, which is has been there for a long time, and it's a very popular framework out there for testing. It's basically a web automation tool, and it supports multiple programming languages such as Python, like, Java, C Sharp, Ruby, and make it very easy for developers to write scripts, test scripts in the language that they are most comfortable with. And it also supports multiple browsers as well. And one thing knowledge that Selenium has a large and very active community, making it easy to find help and resources if you get stuck. And also it has offers like wide range of functionality, like including ability to interact with pages, fill up forms with buttons and navigate between pages, making it like really useful for both web testing and also some other functionalities as well. And then you have Cypress, which is once again a very popular framework. So it's basically it's a JavaScript based framework, and it has built-in support for like testing, popular development frameworks like React, Angular, and Vue.js. It is really useful for developers. And Cypress has like built-in test runners for running scripts, which is really useful. It eliminates like the need to use like other tools for like for example in the case of Selenium, you have to use like Selenium WebDriver to run your test. But in Cypress, you have these test runners built in, which is really useful. And Selenium, for example, requires like a lot of additional tools or libraries for running and a certain tests, but Cypress it has built in. One disadvantage of Cypress is it doesn't support mobile testing. While on the case of Selenium, you can do mobile testing with use of Appium, another framework that I'll come to in a while. And you have Playwright, which is a relatively new testing framework, which it's actually a Node.js based framework, and it's run by Microsoft. And it's actually an open source tool. I forgot to mention Selenium and Cypress are both of them are open source tools as well. Selenium and Playwright as well. It's also open source, and it's cross platform and it's cross browser. So it can depend doesn't matter what the platform is, and can use in multiple browsers and multiple languages. You can use it's cross language, and it includes a lot of helpful features. And it's far newer than Selenium, and it has, since it's moderately like considerably new, it has like very modern APIs and supports much more of modern web features. And then you have Appium, which is especially for mobile app testing. And then you have JUnit and YUnit, which is for like a unit testing framework. So JUnit, in the case of JUnit, it's used for like running unit tests on Java, and PyUnit is for like unit tests on Python. And then finally, you have Postman. I'm pretty sure you've heard of it by now. It's a very popular tool used for API testing. So as you know, as I mentioned earlier, API is how components of software communicate with each other. For example, front end and back end. So it's really important to make sure that your APIs are working correctly and the data is or JSON messages are going through. to the other side. So that's where tools like Postman comes in. It allows you to, it has a lot of functionality and allows you to test your APIs. Right. So these are some of the popular testing frameworks that I just listed out. There's a much more of up and coming frameworks out there. I suggest that you explore on your own. So that's the next point that I'm coming to. I've basically finished my um, like presentation slide. So finally, one thing I have to mention is that I've just like listed out and some of the technologies, some of the popular technologies, and you know there are a lot of technologies out there that might be really fitting for what you are going to develop. So what the best thing to do, I think, is to search on your own. There are a lot of, you can just write simply type on Google as well, and there's to like that GPT as well. You can ask that as well. So first take your project, topic, the thing that you're building into consideration, and then go from there in trying to search and come up with their technologies and frameworks and testing frameworks as well. And then finally, I mentioned this before, when you're learning technologies, try to learn like the concept behind the technologies like comprehensively. So that's what will be really important when you're going to the industry, when you're moving forward into your future. So that keep that thoroughly in mind as well. That's it actually for my session. I hope you learned something valuable from my session. And if you have any questions, feel free to message me on LinkedIn and clarify doubts. And yeah, hope you learned something new. And very best of luck with your project. A very good night to you. Over to you. You know.
Yeah. Thank you so much, Saya. And I hope you all learned a lot of things from this session as well. And yeah, guys, feel free to drop your questions in the chat box as well.